Bismillahirrahmanirrahim. Assalamu alaikum. Today's discussion topic is forces in a free body diagram. Well, in a previous lectures, we are discussing contact forces and non-contact forces. There are different type of forces are acting on an object. You can see an example of this one. A book is laying on that table. There are different type of forces will be exerted on the table, and table exerts a force on book. External forces acting on an object may include friction, gravity, normal force, drag, tension in a string, or a human forces due to pushing or pulling. There is an example, there is a definition. This is a definition of free body diagram. Are used to show the relative magnitudes and direction of all situation. In other words, a free body diagram is a special example of a vector diagram. This is our definition. You must be marked or underline. You can see figure 3.8. This is this is a book which is lying on at that table. Here, a book will be exerting a force, will be a downward, weight is a downward, and it is a opposite force, will be a normal force. Let's suppose we are considering, we are applying a force toward in this direction to move the book, and that is a opposite direction, opposite force will be a friction. Let us see the object is represented by a box and the force arrows are drawn outward from the center of the box in the direction of forces. The length of forces arrows reflects the magnitude of force and the arrowhead indicates the direction. By using a vector, if we want to represent a vector, we using a vector form, and that is arrowhead will be shows the direction of the vector. The second topic is Newton's law of motion. Newton's first law of motion. It is represented by Sir S. Newton, was born in Lincolnshire on January 4, 1643. The name of his famous book is Principia Mathematica. न्यूटन्स ने फर्स्ट लॉ ऑफ मोशन एक्सप्लेन किया था, जिसमें उसने ये बताया था कि एक बॉडी अगर इन स्टेट ऑफ रेस्ट में है और इन स्टेट ऑफ मोशन में है, इट विल बी रिटेन सेम इन स्टेट ऑफ रेस्ट और स्टेट ऑफ मोशन until we are applying an external force. This is called first Newton's first law of motion. It is a common observation that a force is required to move or stop a body. A block placed on a table remains there unless a force is applied to move it. I will give an example of this book. A book is lying on that table. It is in state of rest. If I can apply a force, then it will move from one point to another point, just like a pencil. It is in a state of rest until if I am applying external force, and it will be moved from one point to another plane. The ball stops after covering some distance. In fact, an opposing force, friction, causes the ball to stop. Newton expressed such observations in his first law of motion. Please underline these yellow box. A body continues its state of rest or uniform motion in a straight line unless acted upon by some external forces. This is a definition of a first law of Newton. It is an example. Give a heading example. When a fast moving bus stops suddenly. कहते हैं कि अगर हमारे पास एक फास्ट रनिंग बस जो है वो अचानक से स्टॉप कर जाती है, तो पैसेंजर्स क्या होते हैं, दैट विल बी मूव फॉरवर्ड. इट इज़ बिकॉज दे वांट टू कंटिन्यू देयर मोशन. On the other hand, when a bus starts moving quickly from rest, the passengers are pushed back against the seat. This time, the tendency of passenger is to retain their state of rest. According to first law of motion, a bus moving on the road should continue its motion without any external force exerted by an engine until we see that if an engine stops working, The bus comes to rest after covering some distance. It is because of the friction between the tires of the bus and the road. All the bodies moving on the earth are stopped by the force of friction. If you were in outer space and throw an object away where no force is acted upon it, the object would continue to move forever with the constant velocity. First law of motion also provide us another definition. Please underline another definition of our Newton first law. Force is an agency which changes or tends to change the state of rest or uniform motion of the body. कहते हैं कि फोर्स रीजन बनती है किसी भी ऑब्जेक्ट की स्टेट ऑफ मोशन और स्टेट ऑफ रेस्ट को चेंज करने में. Just like an example of a ball, if I am hitting a ball, it means I am hitting a ball by an external force. That ball will be moved in a state of rest, or if it will be in state of rest, it will be applying a force to provide for motion. In first law of motion is also known as a law of inertia. What is an inertia? Inertia is the property of body to maintain its state of rest or state uniform motion in a straight line is called inertia. Let's explain with an example. Let us consider we have a bicycle which is moving in a straight line. We are applying some force to stop the bicycle. Can is it possible that the same amount of force if we applying on a truck it will be change the motion of the truck? No, it's not possible because it depends upon the mass inertia depends on the mass of an object. The more mass the more inertia, the less mass the less inertia. It is a direct relation. The mass of an object is measure of its inertia. The greater the mass of an object, the greater is the inertia. Please underline these points. The mass of an object is measure of its inertia. The greater the mass of an object, the greater is in inertia. As a result, the role of inertia in Newton's first law, this law is sometimes called as law of inertia. Newton's second law of motion. Newton's first law indicates that if no net force acts on an object, then the velocity of an object remains unchanged. But in a Newton's second law of motion, we will study the relationship of acceleration with force. Acceleration produced in a body when a net force acts upon it. Newton's second law, please underline this portion. This is a definition of Newton's second law. If a net external force acts upon a body, it accelerates the body in the direction of force. The magnitude of acceleration is directly proportional to the magnitude of force and inversely proportional to the mass of the body. इसमें क्या वो explain कर रहा है? It will be explains acceleration will be directly proportional to a force. Force will be increased. Acceleration producing in a body it also increases. And acceleration is inversely proportional to a mass. It means acceleration will be maximum when mass of a body is less. And if mass of a body is increases, acceleration will be decreases. Acceleration is directly proportional to force into the mass. Acceleration is equals to constant F over m. According to SI unit, if mass is equals to 1 kilogram, acceleration will be 1 meter per second square, then force equals to 1 Newton. The value of the constant will be 1. Now class, look at over here, acceleration which is equals to 1 multiplied by F over m, m will be cross multiplied with a, F is equals to ma. This is the force will be equals to a product of mass into an acceleration. First law of motion provides the definition of force. A force produces an acceleration in a body. It gives a value of Newton's second law of motion. We calculate mathematically the amount of force required to produce a certain amount of acceleration in a body of known mass. The SI unit of force is Newton N. This is a definition of a 1 Newton. 1 Newton is the force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. 1 Newton will be equals to 1 kilogram meter per second.